This video will be covering a PowerPoint on gas tungsten arc welding a pipe part 2. So I already covered part 1 and this one's going to be part 2. So, concave root surface. A concave root surface, also known as suckback, occurs when the backside of the root weld is concave in shape. So as you can see it right here, concave root surface. Concave root surface continued. Common causes for this condition are when insufficient filler metal is added to the joint or excessive heat is used in the overhead position. The concavity of the root surface results in reduced thickness of the actual throat of the weld, which in turn causes a lower joint strength. The amount of concavity can be given as a percentage of the total weld length, as the average number and largest size of spots per inch of the weld, or as a percentage of the effective throat. Normally a 1/16 is the maximum allowable root concavity. Excessive root reinforcement. Excessive root reinforcement or burn through is the excessive buildup of metal on the backside of the weld. Uneven buildup and burn through are sometimes referred to as grapes. This condition results from excessive heat, temperature, and filler metal during welding. The amount of excessive reinforcement is given as a percentage of the total weld length, as the average number and largest size of spots per inch of the weld, or as a maximum distance from the metal surface to the longest spot of excessive reinforcement. Excessive root reinforcement continued. The root of the weld should have some reinforcement or buildup, but should not exceed 1/8 of an inch. Visual inspection can be used to verify this condition. So whenever you're welding TIG with TIG on pipe, typically you can be flush to 1/8 inch, but it can't be underfilled and it can't go over that 1/8 of an inch. Root contamination. The backside of the molten weld pool can be contaminated, causing porosity, embrittlement, oxide inclusions, and/or oxide layers. Contamination is caused by overheating, poor cleaning procedures, or improper protection from the surrounding atmosphere. Root contamination continued. Root contamination can lead to faster corrosion, oxide flaking, weld brittleness, leaks, stress points, or all of these. Backing gas. So specifically for this Weld 208, which is TIG all the way out pipe, we're using carbon steel, mild steel. But if you want to practice with stainless steel after you get your 2G, 5G, and 6G done, you can practice on stainless steel pipe, and this is whenever it's getting into purging and backing gas. So backing gas. The easiest method of protecting the root from atmospheric contamination is to use backing gas. The type of gas used for backing will depend upon the type of pipe being welded. Purging. There are several methods in common used for containing the backing gas in the pipe. When a backing gas is used, the gas must have enough time to purge the pipe completely of air. When welding on large diameter pipes or long pipe sections, it is necessary to estimate the length of time required to purge the air. With that being said, if you get to stainless steel pipe, I will go over how you're supposed to purge, the amount of time, and we'll be able to calculate that in class, okay? When welding on large diameter pipes or long pipe sections, it is necessary to estimate the length of time required to purge the air. First, estimate the interior volume of the pipe. Second, convert the flow rate into cubic inches per minute. Third, to get the time required, divide the estimated volume by the flow rate. Last, round any fractions of minutes off to the next highest minute. This is something that we can go over in class, so just so you know the actual mathematical value of this. Purging continued. There are several methods in common used for containing the backing gas in the pipe. On small diameter pipes or short sections of pipe, the ends of the pipe are capped. So as you can see, here's your pipe, here's the caps on both ends. And then you have your backing gas hooked up to a hose that would be going into your pipe, okay? And then you would have, where you're not welding, it would be taped off with some type of tape, just so that gas isn't escaping from there. Purging continued. Taping over the joint prevents the gas from being blown out through the joint. This will allow a slower flow rate to be used on the purging gas once the pipe has been purged. The tape is removed just ahead of the weld. So as you can see, the vent hole, the seal that's in place, and then here's your tape, okay? So it's covering the groove where you're not welding at, and then where your welding is going to be opened up, all right? Filler metal. The addition of filler metal to the joint can be done by dipping or pre-placement lay wire. Dipping can be made easier if the rod is bent to the radius of the pipe. Filler metal continued. Replacing the filler rod, lay wire allows a root pass and some filler passes to be made without rod manipulation. This was talked about in previous videos about lay wire, about dabbing, about walking the cup. So depending on what your preference is depending on how you're going to weld up the pipe, okay? This is just going over certain things that you could possibly do when you're welding pipe, but of course learn the right technique that allows you to get the right penetration for your root. Consumable inserts. Consumable inserts are pre-placed filler metal which is used for the root pass when consistent high-quality welds are required. Inserts are classified by their cross-sectional shape and listed as follows. So Class A or Class 1 A shape, so it looks like this. Class 2 J shape, so it looks like this. Class 3 rectangular shape, looks like this. Class 4 a Y shape, so it looks like this. And then Class 5 rectangular shape, contoured edges, so it's a little rounded, okay? So those are consumable inserts. Consumable inserts continued. So there's specialized backing rings, so you'll actually put it on the inside of your pipe, okay? This is something that we can also go over in class. That's the end of part 2 PowerPoint. After this PowerPoint, I'm going to upload a part 3 PowerPoint. That way it covers a little bit more. So make sure you're checking your D2L and watching these videos and following along with the PowerPoint that's attached. If you have any questions, please reach out to me. Thanks.